right, so in this video, lesson 2.8b, we're going to go over some practice problems related to calculating calories. All right, so something that would be helpful would be to have the equation on a scratch sheet of paper on the side as you do these problems with me. All right, so the first question asks, how many calories is in the butter? So we're looking for how many calories, right? And remember that calories is our Q. So to solve this, I need to find what M is and then multiply it by C, our specific heat, and then multiply it by delta T, or our change in temperature. So let's first start with figuring out what M is using this table above. So recall that in lesson 2.8, we mentioned that all of the energy from our food is being transferred to the water. So we're not looking for the mass of the food, we're looking for the mass of the water because that is the thing that we are transferring all of the energy to. So here, the mass of the water is 100 milliliters. And remember that 1 milliliter is the same as 1 gram. So if I have 100 milliliters, that's going to be 100 grams. So therefore, the mass of our water is going to be 100 grams. So when we're measuring calories or finding calories in food, we're always using the mass of the water. All right, so that's our M. So let's talk about C, our specific heat. So remember, specific heat is how easily something heats up or how much energy does it hold. Right? So in this case, because we're transferring the energy into the water, our specific heat is going to be of water. And the specific heat of water is always 1 gram per calorie degrees Celsius, right? Don't worry about the units too much if that's confusing you right now, right? But know that the specific heat of water is always 1. So every time we do a problem, know that your C, or specific heat, is always going to be 1, right? As for delta T, this is our change in temperature. So how much did the energy go up or change by? Think of this as one variable, right? And to find the change in temperature, we need to take the final temperature and subtract it from the initial temperature. So our final water temperature is 120. I'm going to need to subtract it by the initial water temperature. Sorry, my dog's snoring in the background, so it's making me laugh a little bit. Minus 20. So final water temperature 120 minus initial water temperature 20 will give me a change in temperature of 100 degrees Celsius. Right, so now I have each of my variables completed, and in my calculator, I'm just going to multiply these 3 variables. Right, so starting from the beginning, my M is 100 times my specific heats of 1 times 120 minus 20, which is 100. So I can either do this in my head or type it into a calculator, and I will get a total of 10,000 lowercase c calories. That is my final answer. All right. So what if I have to find the answer to the second question? How many calories per gram is this? Right? So oftentimes when we read nutrition facts, we'll find that it's by serving. So how many calories per serving is that? So how do we figure that out? Well, let's do that problem next. I'm going to erase everything on here, so feel free to pause and write this down if you need to. All right, so let's try this problem that says how many calories per gram is in the butter. So to solve this one, I need to know how many calories total did we calculate? So that was the first problem, and we recognized that it was 10,000 calories from before. And if I want to figure out how many calories per gram is in the butter, I need to know the total calories. And I'm going to divide that with the mass of food that actually burned. So oftentimes when we do calorimetry and we burn things, not all of the food burns. So some of the food remains as matter and did not convert into pure energy or heat that then went into the water. So therefore, we need to only take into account the mass of the food that burned by taking the initial mass and subtracting it from the final mass. Right? So in this case, if I have 10,000 calories, I'm going to divide that over my initial mass of food. So initial mass of food is 16. I'm going to put a parentheses around this because I'm going to do the subtraction for the denominator first. Let me just change that to this too, so that it's more clear. Minus 14 grams of food. Right, so here, if I do the math, I can recognize that, hey, only 2 grams of food actually burned and caused this amount of temperature change, right? There was still at least 14 grams of food that did not burn. So if that's 10,000 calories, we keep the colors the same. So to find the calories per gram of butter, I would take 10,000 divided by 2, and that will give me 5,000 calories for every gram of butter. And notice that this is lowercase c calories, right? And we mentioned that there's a difference between lowercase c calorie and capital C calorie. Specifically, that's 1,000 lowercase c calorie is equivalent to 1 capital C calorie, right? So if I ever were to ask you how many capital C calories this would be, as you would label in the nutrition facts, you would just divide this by 1,000, right? And 5,000 over 1,000, you can type it into your calculator or cross out these extra zeros and just recognize that that's 5 capital C calories, right? But since I did not ask that here, this would be your final answer. How many calories per gram? Calories per gram would be this. Okay, so this time we have a harder problem, a word problem that says you have a 5-gram sample of cheese that raises the temperature of 50 milliliters of water from 20 to 42 degrees Celsius. Let's start with the first question. How many calories can be found in the cheese? So again, if I'm looking for calories, I'm looking for Q, or heat energy. Calories is our unit for heat energy. So to solve this, I need to find M, C, and delta T. So as I'm reading this problem, when I'm looking for mass, I'm looking for milliliters of water, right? So if you think you've got this, feel free to pause this video and try to solve it yourself, and then fast forward to the part where I give you the answer, right? So here, M is the mass of water, because that's our thing absorbing the energy. So here, it's going to be 50 milliliters or 50 grams of water. What is C? C is our specific heat of water, and it is always 1, right? So if you just want to write that in your notes, specific heat when we're calculating calories of food is always going to be 1. What about delta T, or our change in temperature? Right. So here, our change in temperature, notice that it says raises the temperature of 50 milliliters of water from 20 to 42 degrees. So here is my final temperature. I'm just going to write TF. And my starting temperature or initial temperature is going to be 20 degrees. Right? And to find my change in temperature, remember it's the final temperature subtracted with the initial temperature. So that's going to be 42 minus 20, which will give me 22 degrees Celsius. So again, now that I have all these variables, I'm just going to add it to my calculator. 50 times 1 times 22. So each of these number variables here, and type that into my calculator. 50 times 1 times 22 will give me 1,100 lowercase c calories. Right. So that is the response for the first question. All right, so let's talk about the second question now. Boop, boop. All right, how many capital C, so notice this says capital C calories, would be listed on the nutrition facts label? So for the second question, you need to remember one tiny little thing that I mentioned in the previous problem, right? The fact that 1,000 little c calories is equivalent to 1 capital C calories. And this is what you see on your nutrition facts label, the capital C calorie. So if this were to be written on the nutrition facts, what would it say? Well, we know that we have a total of 1,100 lowercase c calories. So I'm just going to divide by 1,000 to get capital C calories. So here I would end up with 1.1 capital C calories. This is the same thing as unit conversion because 1 capital C calorie is actually a kilocalorie. So another way you can think about it, if you don't want to, if this is confusing, if you recall when we were doing our unit conversion, kilo, hecto, deca, and then the base. So lowercase c calories here is our base. This is our kilocalorie, or capital C calorie. So we're moving 1, 2, 3 spaces to the left, right? So if I go back and take this original number, right, and do the same thing, 1, 2, 3, I'll end up with 1.1 capital C calorie as well. So there's 2 ways to solve it. I can either just divide by 1,000, and I will get the answer 1.1 calories. Or I can remember that a capital C calorie is just a kilocalorie, and it's the same thing as unit conversion. And I'll still end up at 1.1. Either or methods will get you to the results of what a capital C calorie is. All right, so this is the last type of problem that I'm going to solve. It's essentially same thing as calories per gram, but for this problem with the cheese, right? And if you feel like you've already gotten this, feel free to skip ahead to the next slide for the practice problems. Or if you're like, I'm still not sure about this in terms of calories per gram, feel free to watch this help video as well. Right, so earlier we found that the cheese has 1,100 calories, right? And the second question is the question that I'm just going to answer for this slide. Assuming only 2.5 grams of the sample completely burned off, how many calories per gram is this, right? So remember that if I'm looking for calories per gram for this particular question, then I'm going to take my total number of calories. Excuse the messy handwriting. Total calories divided by the number of calories that burned, right? So it would be the mass of the food the initial mass minus the final mass of the food, right? So here my total calories is going to be 1,100 as I solved earlier in the previous slide. With the initial mass minus the final mass. So my starting mass is 5 grams. And I recognize that only 2.5 grams of the sample burned. So to solve, I'm going to first subtract the denominator, right? So it's going to be 1,100 over 2.5. So to simplify again, I'm going to take 1,100 and divide it by 2.5 in my calculator. And when I do that, I should get 440 calories for every gram that burned. Right, so at this point, feel free to rewatch any of the videos or reach out for help by emailing me or messaging me in the chats. And then the next slides are 2 practice problems for you to do with an answer key at the end, just to make sure that you're good on the steps. And I tried to color code everything so it was clear where the numbers were coming from.